Okay, hello and welcome to Meetup number 71. This is the Beginners Python and Machine Learning group, and the first week of every month we do a session for absolute beginners who've never seen Python before, and so that's what we'll be doing this week. My name's Tim Cummings, and I'll be running the session tonight. So if you look at the Google page where you're watching this, down below you'll see a link to a Colab document, and that's what we'll be using to run through the Python exercises tonight. Colab means that you don't need to have Python installed on your computer because we'll be running Python that's installed on a Google server. And so that means that there's no setup required from you apart from an internet connection. And that you, yes. So click on the link in, it's either on the Meetup page or also on the YouTube page, and that'll take you to the notebook that we're going to start with. And this is giving you a copy of my notebook. A notebook is where we can run Python, but you're going to need to save it and save a copy of that so that you can actually make some changes. So if I say save a copy in Drive, it'll copy it into your Google Colab account and give it a new name. You see it's now called Copy of Meetup 71. So if you want to, you can rename that. So like I could rename that to Solutions for Meetup 71 just by clicking on it and typing in the new name. And what I'll do, I'll share the solutions one. I don't think you need it, but some people like to have a look at stuff that I've typed in during the session. So let's see, change to anyone with this link will be able to use it, and I'll post this. We've got a channel on Slack, so hopefully you've signed up for that. So I'll just post the link on Slack, and I'll try to post it on the Google chat as well. But I think sometimes the Google chat disables links. So there you go. I've posted it just under Peter's comment, "Hey Tim," and so hopefully you'll get that. But if it doesn't show up, then try looking in the Google in the Slack chat. All right. So this is just a web page. So you can treat it just like another web page. We can scroll through it. I'm just scrolling using the wheel on my mouse, and it's going to go through the things that we're doing tonight. So tonight we're looking at interactive Python, which is this particular sort of Python that we use in notebooks. We're doing coding, functions, branching and looping, and we're using Colab. If you do want to install Python on your computer, I'd say install Python 3, don't install Python 2, and you can get that from python.org. And I'd also recommend a integrated development environment such as PyCharm Community Edition, which is free. The latest version is actually now, they've just come out with 20.2. So this was the one when I prepared this, was the latest version. So installing that gives you a few extra features and helps you along the way in writing your Python programs. Okay, so you might see different references to Python. There's one called IPython, which is interactive Python, which has really been extended into Jupyter Notebooks, and Google Colab uses Jupyter Notebooks, so that's what we're using tonight. But then there's just straight Python, and you can do all these exercises in straight Python as well. And if you want a copy of the Python version, just a straight Python version of the notebook, it's available on our GitHub site at that link. But Jupyter notebooks are a great way to learn because you see the results immediately, and it's very interactive, and I find that's a better way for learning. So in the notebook we have cells. You can see these grey shaded areas. That's a cell. There's another cell. As I hover over it, I get a play button. So I can run code that's in a shell. I can click on the play button to run the code, or I can hit Shift Enter to execute the cell. There's also these bits of text. That's been put in using a thing called Markdown text, but you don't have to worry about that. We're just going to be concentrating on Python code. So here's a little bit of Python code. It doesn't do anything. It's just a hash sign followed by some comments. And then any of the text that comes after that's totally ignored by Python. But it's useful to write a story in there to explain to people what's going on. So and often that's the person you're explaining to is going to be yourself, your future self. When you come back and read some of the code that you've written and you go, why did I write that? And the comments will explain to you why you did that. So in this case, we've got some comments that just tell us how to run a cell. It's just saying click Shift Enter. And we've actually got one thing here. We've got a question mark. This is for IPython. If you're using Python console or normal Python, you would use help instead. But here we can use help or question mark. So I'll demonstrate the question mark. So I'm going to press Shift Enter. And see it starts to run the code in that cell. And the very first time you run anything in Google Colab, it takes a long time because it's actually starting up an environment for you. And here we go, IPython and Enhanced Interactive Python, and it tells you all about it. You can make that bigger so you can read it, read through that. It tells you how to do help. You can do question mark in a word. If you want help on a particular word, you can do double question marks on words to get more information about them. And yeah, access to all the source code and stuff. So there's plenty of keyboard shortcuts in here. So I'd also suggest going up to the Tools menu, and if you look under keyboard shortcuts, you'll see some of them. The most common one would be to insert a cell. You can do that from the menu, insert a code cell or a text cell. So Control M and a B will create a new cell below the one you're currently in. Anyway, so we've run that. The little one up there says that it's the first one to be run. Okay, so now I'll give you a bit of an introduction to coding. When you're writing computer programs for a computer, you're really just putting down commands, telling a computer what you want it to do. So computers are very fast at running commands, but the commands that they can run are rather simple. Yeah, there's good and bad. So for example, if we want to display the number 5, we use the print command, and we say a 5 is what we want to display. So if I press Shift Enter on that, I see it shows me a 5. So it's a very simple thing for it to do. But and it did it reasonably quickly. And if you put most of that time is just starting up the cell, running it, and then stopping the cell. And actually doing all the commands in the cell is very, very quick. In IPython, which we're in now, we don't even need the print. We can just put down, say, a number, say 4, and it will show a 4 for us. So whatever the result of the last thing to be run will show in IPython as the output. Now, feel free to ask me any questions on either the Slack chat or the YouTube chat. Remember, this is absolute beginners, so any question is fair game. Some people might even be falling behind at this stage. If there's anything over what I've done so far, please feel free to ask questions about it. Okay, so we're getting up to a more advanced program now. It's going to have 2 commands. We're going to print the number 4 and the number 3. And what the way the programs work is it runs sequentially through those commands. It starts at the top and just goes through them. So if I run those by Shift Enter, you can see it prints a 4 and then a 3. Now if I was in IPython, which I am, I can think that I can use it without the print command, but unfortunately it's just the last result that gets printed in IPython if you don't use print. So if I just said 2 and then 1, and I try running that, it's just going to give me the last one, which is a 1. Okay, so I've left an empty cell here for you to attempt this first task. And you really learn a lot by typing things in and seeing how they go. So here's a cell. The task is write a Python program to count down from 5 to 0 and print those numbers on separate lines. So how would you do that? If you want, you can pause your video at this stage and have a go at it, or just if you think you can do it while you're listening to me, that's good as well. I'll just start doing a simple way of solving this. We've seen that we can use the print command. So I can print 5, then I can print 4, 3, 2. And so often in programming, you don't have to be clever. You just try to think of something that will solve the problem. And then later on, you might be able to look at it and improve on it. But don't try to be clever right from the start. Just try to think of how you might solve the problem. And there we go. We've got a solution that solves the problem. We just put print commands for each one of the numbers. There's nothing special there. I've provided another solution here. So let's run this solution that's been provided here. And you can see this is a different way of doing it. This one we've got the text coming out, so the words 5, 4, 3, 2, 1, 0 rather than the numbers. So text is a different sort of a data type to numbers. And text, we call it strings because it's a string of characters, and we denote that they're going to be strings by putting quotation marks around it. Now we could have used single quotes, we can use double quotes as we have in this case. There's also a couple of other ways of doing it. So in Python, if you want to see what data type it is that you've used, they give us a function here called type. Just like print was a function, so print had parentheses and we put in what we wanted to print. Here, if we want to find the type of something, we use type as the function, and inside type we type what we want to find the type of. So the type of some letters enclosed by quotation marks is going to be an str, which is short for string. So that's what Python calls strings, strs. Similarly, the numbers that we were working with here, they were integers, which Python calls ints. So they're integers because they're whole numbers. They don't have anything after the decimal place, and so they don't have a decimal place. They're just whole numbers. But you can also use real numbers in Python with decimal places, and they're stored in a type called float, which is short for floating point numbers. Now Python can do arithmetic on these numbers, and this what I'm going through here, we covered mostly in Getting Starting 1, but I'll cover it again here now, and if you've got any questions about it, ask me, but I will go over it fairly quickly here. So in any of these cells we can type in arithmetic formulae, and Python will evaluate that, especially IPython will evaluate it and display the result. If you just in straight Python, it'll evaluate it, but it won't show you the answer if we just type in 1 times 2 plus 3 times 4. So that's calculated the result and shown us what the answer is, 14. And you can see it's it's used the asterisk are multiplied, the plus is addition, and it's also done the order of operations. So it's done 1 times 2 first, and then it's done 3 times 4. So it's got 2 plus 12 and added those together to get 14. So it understands the BOMDAS rules of what order you use these operators, and it's done them rather than going strictly from left to right. Now we can save the results from these expressions into memory locations, and we can call these memory locations any name that we like. There's a few Python keywords we need to avoid, and it's also good if you avoid using names of libraries, functions, and data types. But just come up with names to start with, and if you hit a problem, then you'll realize that you just have to change the name. These memory locations are called variables because the values in them can be changed, they can vary. And so, for example, if we wanted to put the number 5 in a memory location called A, or we call it now variable A, and then we can print out the memory location, what the value of that memory location is using the print statement. So if I shift enter on there, you see it now prints the number 5 because that's what is stored in A. So I can do a couple more expressions here. I can do 2 to the power 32. So that's what the asterisk is, and store that in memory location B. I can multiply A times B and store that in C. And then if I want to print out all 3 values, A, B, and C, I can actually use the print command and put commas between the values, and it will print out all 3 values. And so we can see A is 5, and so it's remembered that from the previous cell. B is 4 billion, and that's 2 to the 32. And C is 5 times 4 billion, which is 21 billion. So I always remember like a 32-bit number is 4 billion, and that's why I know that 32 bits is not enough to store the population of the world. So because the population of the world is greater than 4 billion. It's also, if you've got a 32-bit operating system, you can only access 4 gigabytes of RAM, and if you need to access more RAM than that, you'll need a 64-bit operating system. Okay, so we've seen how to write a few programming commands, and we put them in sequence, and the program runs from the top down, one by one, runs each line. But it would be very cumbersome if we had to type a line for every command we want to execute. So if we wanted the computer to execute 1 million lines, we'd have to type in 1 million lines, which would take us a long time. So we can repeat particular commands by putting them in a loop. And what we do is we say to the computer, these commands are in a loop, and we want to just keep repeating them over and over again for a certain number of times or until some condition is true. And these loops, there's 2 sorts in Python. There's a while loop and a for loop. So I'll show you how a for loop works. For loops have a variable in them which changes a value every time you go through the loop. So I start the loop here for Z in 543210, and then all the commands that I want to be in the loop I indent. And this is really important in Python and different to just about every other language, is that Python works out what commands are in the loop by how much they're indented. So we've indented these 4 spaces, and that's the convention. When you are using Google Colab, often Google Colab will default to 2 spaces, and that will still work. So if you're comfortable with 2 spaces, then do that. But in general Python, the convention is to use 4 spaces. And these 2 commands are indented 4 spaces, so they will be repeated. And then this command here, we've got rid of the indentation, and so we're saying that's no longer in the loop. So there's only 2 commands in the loop, And every time it goes through that loop, the value of z will change. The first time we go through the loop, z will have the value 5. The second time we go through the loop, z will have the value 4. Third time 3, 2, 1, and then 0. And I've put a print statement in here, a couple of print statements, so we'll be able to follow what the program is doing by seeing when the print statements run. Now, one of the other things this program is doing is we've got a variable we've called total, and we're putting the number 0 in that. And then this plus equals means add to the current value, the value of z. So every time we go through this loop, total gets incremented by the value of z. And then at the end, we find out what the total of all the numbers is by this print command. So there we go, we ran it. The first time through the loop, total went from 0 to 5, and then we printed z, which was 5. Then the second time through the loop, total went from 5 to 9, and then we printed z, which was 4. So you can see the 4, the 3, the 2, the 1, 0. So they're all in the loop, and then this last statement is outside the loop because it's not indented. And you'll see at the beginning of the loop, or beginning of any code block, this is a code block because it's indented, you generally have a colon. So I've got a colon at the end of that line in the for statement. So the format of a for statement is we start with a for, we have a variable name, and then we have in to say and give the range of values that variable is going to have, and then that iterable list of values. So it will just mean something that will produce a single value each time we go through it. Okay, so now task 2, rewrite the loop to show a running total as it loops through all the numbers. So have a go at this. I'll start typing slowly in, so you can just follow me, or if you think you can work it out yourself, just have a go and ignore me, and then we can compare answers at the end. So once again, we're going to have a total. Now we need to reset it to 0. Then we're going to go through the same loop. So let's do that for z in, and we do 5, 4, 3, 2, 1, 0. And then we put the colon at the end. So these are parentheses that I've surrounded them in. And you see Google Colab's automatically indented for me. It's going, you're starting a loop, I know you want to indent. So the adding up of the total is going to be the same. So there's no difference there. Really the only difference is going to be in our print statement, because we want to print z and we want to print our running total. Okay, and that's all. That's really a solution for the task. And so we can see, as we hypothesized before, we had a 5 and then a 5, then a 4 and a 9. Add a 3 to that, we get 12 as the running total. Add 2, we get 14 as the running total, 15, and it stays at 15 when we add 0. So I hope you're not having too much trouble with these tasks. Remember, it's for absolute beginners. So if there's anything that you're not understanding at this stage, please ask a question. All right, now I've provided a solution here, and this solution I've provided using the while loop rather than a for loop. So you can see the difference in the way it works. So in a for loop, we provided an iterable range of numbers there that produced a number every time, or a value every time that we could use each time through the loop. In a while loop, we just have a condition. And so the while loop will keep looping while that condition is true. So we're comparing z to be greater than or equal to 0. And so whenever z is greater than or equal to 0, it'll run through this loop. And the last line of the loop is to reduce the value of z by 1. So you can see this is more lines of code to get going. But if we were doing, say, 1 million numbers, then this would be less typing than having to put 1 million numbers into this for loop. So this is a different way of writing the code, which is going to be better suited to some of your problems. So if we'll run that, and we can see I've put a bit more text in the print statement to make it a bit clearer what's going on. So the number 5 is Z, and the running total is 5. Yeah, so they all are as we want. Now you just have to be very careful when you're doing a while loop that you put in a command that will actually change the value of this condition, because otherwise you will end up with an infinite loop and it'll just keep looping forever and ever. So if you forget to put Z minus equals 1, that loop will just go on forever. And if you have forgotten to do that, I think you'll find in Google Colab there's a break button over here just where the play is, so you can click on that to try to stop it. Okay, so task 3, we're going to write a loop which counts up from 1 to 5 and displays the factorial of each number as it goes. So the factorial n is 1 times 2 times 3 up into the number times. And so you can get big numbers very quickly. So how would we write this? We could use a while loop for this one. So let's say we'll have a variable which we call factorial, and we'll start that one off. Now we'll start that one with the value 1 because we're multiplying. If we put a 0 in there, anything we multiply by that will return a 0. So I'll start off with 1, and our Z can also start off at 1, and then we'll check while Z is less than or equal to 5, colon, so starting a loop, so we put a colon there, and then it becomes indented. So we want the factorial, and we want to multiply it by itself by a new value, and see how up here to add to a value we used plus equals, and that incremented total. To subtract we use minus equals, so to multiply we can use times equals, which is asterisk equals. Z. And then we'll print Z and the factorial. Okay, and we must remember to do something that will eventually change this condition to false so that the loop stops. And we get factorial of 1 is 1, factorial of 2 is 2, factorial of 3 is 6, factorial of 4 is 24, factorial of 5 is 120. Okay, so in the solution I've shown you a different way of doing this, and this is using the range function. And the reason this solves a few of the problems, like before I was saying if we wanted to go through use a for loop for 1 million times, it would be a lot of numbers to type out in that iterable list. But there's a function range which will provide that list of numbers, and it's got a start value and a stop value. So it'll go up to but not including the stop value. So if I want to run this, we can see what values of Z we get. We get 1 up to 19. So if I say range 1 to 20, it starts at 1 and will continue up to but not including the final value. And that's really a theme in Python and other languages, is that when you're providing ranges, the final value of the range is not included in the range. And it has some benefits. It means that I can count how many numbers are going to be in this range by subtracting the start from the finish. So 20 minus 1 says I'm going to have 19 numbers in the list. So if I went from 10 to 30, then I know it'll go 10 up to 29 will be the numbers that are shown, and the number of numbers that will be shown will be 30 minus 10, which is 20. So I've got no questions so far, so that's all good. I hope you're following. You can see these numbers, which might be a little bit different to other languages you've been used to. The numbers are getting very, very large, and you can get hundreds of digits in these integers, and it'll just use more and more memory to store them. But yeah, they can go very, very large. So this is when you're using integers. When you're using floating point numbers, they'll always use the same same amount of memory. So they will be rounded off to about 17 decimal places. Okay, task 4. Display the first 20 numbers in the Fibonacci sequence. So Fibonacci is a sequence where it starts off with 1, 1, and then every following number is the addition of the previous two numbers. So 2 is 1 plus 1, 3 is 2 plus 1, 5 is 3 plus 2, 8 is 5 plus 3, 13 is 8 plus 5. So we're going to try to write a program that will display this sequence. So what we'll do, we'll have some variables, and we'll store these numbers in variables. So we'll have f1 equals 1, f2 equals 1. All right, and then we want to do this 20 times. So let's use a loop. I'll use I as my counter in the loop. And I use the range function. Now range can be start to stop, but if I leave the first number out, it'll assume 0. So I just want to do it 20 times. And so that means this loop is going to go 20 times. And I don't even need to know what the value of I is each time, but I is the variable that's going to keep track of how many times we've gone through the loop. Okay, so we'll say f3 equals f1 plus f2. So the third number in our sequence is going to be the sum of the previous two numbers. And now I'll print out a number, and I'll print out f1 because we haven't printed anything out yet, so may as well print out the first number. And once I've done that, then I need to prepare for the next time through the loop, which is I need to move my f1, f2 and f3 a bit further along. So at the moment, f1 is 1, f2 is 1 and f3 is 2. And for the next time through the loop, I want f1 to be 1, f2 to be 2, and f3 to be 3. So let's say f1 now equals f2, and f2 now equals f3. And if I run that, I can see I get the Fibonacci sequence 1, 1, 2, 3, 5, 8, and so on. You can see any one of these numbers, 2584 plus 4181 equals 6765. And you can see the first few numbers there, are the first few in the list there. So are there 20? Well, I've got 20 print statements, so I presume there's 20. Maybe I'll print I as well so I can see which one it is. And I goes from 0 to 19. So maybe I should print I plus 1, so I can say. So I plus 1 goes from 1 to 20. So that's the first one, the second one, the third one. And the 20th one is 6765. So let's have a look at the solution, because the solution seemed to do it in fewer lines than I've done and use fewer variables. I needed 3 F1, F2 and F3, as well as the I for counting. And the solution is using a feature of Python, which is fairly unusual in programming languages, and that's multiple assignment statements can be done all on one line. So rather than having one line for F1 equals 1 and another line for F2 equals 1, I can have a list of variable names here on the list left, so F1, F2, and then a list of values on the right, so 1, 1. So that'll put the first value in the first variable and the second value in the second variable. Then I've got my loop that I've got going round 18 times, and we'll see why it's 18 in a minute, where I print F1, and then I have this command here, F1, F2 equals F2, F1 plus F2. And so the first value, F2, gets put into the first variable, F1, and the second value, F1 plus F2, gets put into F2. Now, without that ability to do two multiple assignment statements on one line, I need that F3 variable. But because I can do this now, it actually shortens my program and means that I don't need to have that third variable. So let's run that and see what we get. We get the same numbers all the way up to 6765, just like 6765 here. But what is also interesting is that they've all come out on a single line. And the way we've achieved that is in the print function here, we've added a value for the end character of the print statement, and we've put it in as a space. So we've got a string, we've just used single quotes on this one, we could have used double quotes, it wouldn't have made any difference. And we said at the end of each number, put a space rather than a new line. So up here we've got a new line at the end of each, and this time we've got a space. Then after the 18th time that it's done that, we've got this another print statement which has also gone onto the end and has printed F1 and F2. But because we haven't specified what the end character is in this print statement, it's assumed it's the new line, and so it has dropped a line. In IPython, you wouldn't notice the difference whether we had end as a space or end as a new line, because they would both show the same way. But in normal Python, you would see a difference if you had end equals space at the end of that one. So any questions so far? All right. So task 5, we want to count down in steps of 2.25 from 10.5 to minus 3 inclusive. Okay, so we've seen the range function before. We've seen that can have a start value, a stop value, and a step value. So what would happen if we tried to use that? So if I said for z in range, so we want to start at 10.5, we want to finish at minus 3 inclusive, so I've got to go a little bit further than that, so I'll subtract 1 from that, and we want to go down in steps of 2.25. Print z. So I've run this, but I get an error message, type error, float object cannot be interpreted as an integer. So we can't use the range function to do the start, the stop, and the step. So why don't we use a while function to do this. So we'll start off with z equals 10.5, which is our starting value. We're going to while z is greater than or equal to minus 3, print the value of z, and then decrement z by 2.25. So I could have added minus 2.25 there, or I can just subtract 2.25. So let's run that. And that does what we want. 10.5, 8.25, 6.0, 3.75, 1.5, minus 0.75 and minus 3. So that's a solution for task 5. What's another way we could have done it using range? Well, if we really wanted to use range, all we've got to do is find the lowest common denominator of our fractions. So our fractions, so 10.5 is the same as 21 over 2. Minus 3 is minus 3, and the step was minus 9 on 4. So the lowest common denominator is 4 for those, because we can write all of those in terms of that. So the numerators will be 10.5 times the lowest common denominator. But that will still give us a float number, so we have to convert it to an integer, and we do that by typing int and use int parentheses. So the int function will convert a float to an integer. So even though they've both got the same value, we need it to be an int type to be able to use it in a range. So I'll just demonstrate that. I'll just create a cell above. So I'll just go Control M A. Let's create a cell above. And if I have 10.5 times 4, and that gives me 42.0. And if I do int of 10.5 times 4, so you can see the first value is 42.0, the second value is 42 without the 0.0. And so that one's an integer, and this one's a float. And I need integers to use range. So that's why I've used int here. And I've done that for the start, the stop, and the step. And I've also subtracted 1 from the stop because I want the stop to be, that I've chosen here, to be inclusive. And then I'll print those. And then when I'm printing the values, I then divide by the denominator to convert it back to a floating point number. So there we go, I get the same numbers. You can see at the top of the screen, 10.5, 8.25, 6, 3.75, 1.5, minus 0.75, minus 3. The other thing I've done is I've used format strings. This is getting a little bit advanced for your absolute beginners, so don't worry about it. If you're a little bit confused by that, you could have just printed X over LCD. But I can use a format string. So in front of the double quotes, I put an F. And then in the string, I can put any bit of text. But when I use these curly braces, inside the curly braces, I can put an expression and it will be evaluated. So it's going to evaluate X divided by LCD. And then if there's a colon in there, anything to the right of the colon is the format, how you want it displayed, and anything to the left is the value. So to the right, I've said I want it to be 7 characters wide. I want it to have decimal points showing. I want 2 decimal places to show, and it's going to be a floating point number. And so you can see I've now got all the decimal points lined up, which is unlike what I had before, where they were just all left aligned, and so the decimal points were all over the place. So this becomes a lot easier to read. And so I find format strings so useful that I try to introduce them at quite an early stage for people who learning Python, so that they can become familiar with them quickly. All right, so there's a solution. We've used range and we've used while, so they both seem like pretty good solutions. But there are problems with using the while type solution. And one of the problems is when you're using floating point numbers, they are in fact stored as binary numbers in the computer. So they're displayed as decimal, but they're stored as binary. And when you're storing a floating point number as a binary, if it's a fraction where the denominator is a power of 2, like in our case it was 4, so that 4 is a power of 2, it can be represented exactly, the float can be represented exactly in binary and stored properly without any rounding errors or problems. But if the denominator isn't a power of 2, you will get rounding errors. And that gets demonstrated by this little example here. We're going to start with a value of 1. We're going to keep counting down until we get to 0, and we're just going to subtract 0.1 each time. So we start with 1.0, 0.9, 0.8, everything's looking great, but by the time we get to 0.7, it's just the rounding value in this value of 0.1 has meant that we're now no longer getting the numbers that we expect. And by the time we get to 0, we're 1.3 by 10 to the minus 16 out from 0, and we don't get the 0 that we expect. Now if we did the range with integers and a lowest common denominator to do the same thing, that would have worked. So this is just something to be aware of. We're using integers and floats, and a float is one of the built-in types in Python. There's also a class called decimal, so you can use decimals, and decimals will do this calculation correctly, but it's a lot more typing in your code, and so it's a little bit harder to use. It's nice if you can just type numbers directly in like this, but just be aware of these particular issues. So for scientific applications, this is usually not an issue. For accounting applications, it can be. If your cents don't all add up, then you're going to have problems. So if you're doing accounting programs, then definitely use decimal class, or maybe use integers for the cents. Okay, I've got a question here from Daniel. What would happen if you didn't use a second F to typecast the result to a float? So that's a very good question. So let's do some examples. I'll create a new cell here. So the first F is saying format string, and in there, say we had a number, so 8.33333, and we want to make that, let's say we'll make it 10 characters wide with 3 decimal places and a floating point, and that gives us the string which is right padded, right justified, spaces in the front, and 3 decimal points. Now if I left that F out, I think it doesn't know what it is. It doesn't know that this is going to be a floating point, so I think it's going to have trouble. Oh no, not what I expected. Not sure why it would give that. So you can use different values here. So for example, if you had in the format string, if you had an integer, 345, and you want that to be 5 characters wide and shown in decimal notation, we'll get rid of that dot. We'll do them up close to each other. So it's put 2 spaces and then shown that in decimal. Now maybe I want to show it in hexadecimal. So that'll convert this decimal number and an integer into hexadecimal. So that's 159, not a great example. If I did, say, 255 in hexadecimal, that should be FF. Yeah, FF. I can also show it in binary. So if I put a B there, I get binary. And so that's all the ones. And 5 characters is not really long enough, so it's extended it further than that. You can even do octal, which is an O. 377. So if you don't put a number in there, I think it assumes G So if I put a G in there, yes, I get the same value. Now G is more to do with exponential notation, I think. So let's I'm not sure how it's choosing how many decimal places to display that, but F and G are the two that you'd use for floating point numbers, and for integers you could choose D for decimal, B for binary, X for hexadecimal, and O for octal. I think no. I don't use G very often, so I don't know the options that go with G. All right, so let's introduce a new data type here. It's called the list. So a list is an ordered collection of data values of any type, and the way you define it is using these square brackets, and between each value you put a comma. So I've used all integers here, but I could have used a mix of integers, floats, and strings, and any data type really, even other lists. But anyway, let's start with this list, and I'll print it. Okay, so printing a list looks very similar to how the list was that we created. Now you can append extra values to the end of a list. So it's what we call mutable. It means that you can change the list in place. So we can start off with an empty list that's got nothing in it, and then we can go through a loop 30 times and append a value, and the value we're going to append is going to be 2 times x on the end, and then we'll print the list. So there it is. Our list has got 0, 2, 4. It's got 30 numbers in it, going from 0 to 58. All right, so that was a bit of an aside, and I think it's really to help you with the next task. So this task, we've got some examples of range. So it demonstrates the start, the stop, and the step for each value of range. So I'm going to run this example because it looks clearer when you run it. So examples of range. Range 4 will give us the numbers 0, 1, 2, 3. So it assumes a start value of 0 if you don't provide one, and the number of values will be 4. So 0, 1, 2, 3. If we do provide a start value, 2, 5, then it will start at 2 and go up 2, but not including 5. Similarly, we can provide a step as well. We go up in 4s. So 3, 14, 4 goes up. 3 goes up by 4 to 7, goes up by 4 to 11. And if we went up by 4 again, we get to 15, which is greater than 14, so it doesn't show. Similarly, we can count down. We can count down in 3s, and it'll go 12, 9, 6. But we'll stop before it gets to 3. Similarly, if we go down in 1s, it'll go 12, 11, 10, and it'll stop before it gets to 3 when it gets to 4. But if we did 12, 3, it says it will assume that we're going up in 1s, and it'll say, well, we're already greater than 3, so it won't have any values in that range. So let's see how we've done that. We've got a print command up here. So we're printing range 4 equals, and then we've said don't drop a line, just leave a space. So we've got range 4, and then we've left a space. And then we've done a loop using range 4 that prints out the value of I each time and a space between them, so 0, 1, 2, 3, and then prints a new line. And so it goes down to the next start the next new line. So it's range 2, 5. So range 2, 5, we're printing that. We're going to end with a space. So you'll see there's actually two spaces there. One, because I've left a space here and a space there. So both, there's two spaces there, and then it does the loop 2 to 5 and displays those. Now this time we've done it slightly differently. Rather than do a print all by itself to drop down a line, I've put a new line character into this string. And the way I've done that is with a \n. So \n in Python and in other languages is the new line character. So that's done the new line for us there for range 3, 14, 4. So I'm just showing you different ways of doing this. So once again, we do that. We say what the title of what we're looking for. Then we have our loop using that range to see the I values in it. And then on the next line, the way we put a new line in is we've got a new line in a string. And this is a special string. This one's is delimited by 3 double quotes. If you start a string with 3 double quotes, you can put extra characters in that string, including new lines. So I can just press return on the keyboard and put a new line in here. And so this is all part of the string, including the new line. And so you can see range 12, 3, -3 starts on a new line because of that new line that's in there. And all of these end with without a new line. So here's another thing I'm doing. I'm storing the range in a variable called R. And then when I'm printing, once again, I'm printing \n, and then I'm using a format string because I've got the F out the front, and I'm printing the value of R. And when I print that, it prints range 12, 3, -3. So it's a really nice way of presenting the range object that's stored in value R. It's not an integer, it's not a float, it's not a string. It's actually a range object, but it will display when I use a print command this way, which is what we want. So what is it? 12, this one here, 12, 3, -1. And similarly, range is 12, 3. I put that in the print command as well, and I've used a new line character. So just another way of displaying it. So the task is rewrite this quite long example, but do it using a loop. Okay. So my loop is going to have a variable every time it goes through. And we've seen that we can store range objects in variables. So let's use R as our variable, R in, and then I want an iterable list of range objects. So I could just create a list here. I could use the parentheses as well, that's called a tuple, but we'll get onto that later. But this one's going to be a list, and I'll just put the different ranges in there. So the first time through the loop, I want it just to be range 4. The second time, I want it to be range 2, 5. The third time through the loop, I want it to be range 3, 14, 4. And then I'll just keep going, putting these in. And to start the loop, I'll press a colon. And once I'm in my loop of ranges, now I want to run another loop that's going to run that range. So I indent, my loop is already indented. And I can just say for I in R. And then I want to print I, but don't do a carriage return at the end of the line. And I forgot something here, didn't I? I forgot to print what the range is. So print, use a format string, and the value of r. Okay, and I don't want to do a carriage return at the end of that. And then when I've finished all of that, I'll do a carriage return, a new line. So if I run that, there we go. It prints range 0, 4 is 0, 1, 2, 3. Range 2, 5 is that. So it's pretty close to what we had up here. The only thing that's different is when you do range, you do an R that way, a range object that way, it shows the start. And that's probably a Python thing. Python, it's very unusual in Python to have an optional argument to a function as the first one. It's all, usually the beginning ones are compulsory and then you have optional ones after that. But you can see here, one of the important things in this is we've got a loop inside a loop. And to signify where the nested loop is, we've indented another 4 spaces. So you can just keep indenting as much as you like every time you create a new branch or a loop inside another code block. All right, so let's have a look at the solution. The solution's done it slightly differently. You can decide yourself which way you think is easier to read. So we've created a list of lists, and we've just done the arguments this time. We haven't put the whole word in, range, and the function. We've just created a list of what the arguments are going to be for the range function each time. We've used square brackets around these and parentheses around the outside. So parentheses means a tuple, and square brackets means a list. So really, tuples and lists are mostly interchangeable. It's just a tuple is a read-only version of the list. So once you've created your tuple, you can't change it. You can assign a new tuple to that variable, but you can't change the existing tuple in place. So in this case, I could have used a tuple of tuples. I could have used a list of lists, but I've chosen to use a tuple of lists. But then, if I've got a list of arguments like this, how do I put those arguments into the function? And the way I do that is using this asterisk notation. So this is not really absolute beginners thing in Python, but seems like we're all doing so well tonight, I thought I'd introduce it. What that does, the asterisk explodes all the arguments and just places them in order into the function. So if I've got 3, 14, 4, it just puts them in there in that order for the range function. And similarly, if there's only one argument, it just puts that only that one in. So if I run this, it gives us the same sort of output. I've decided that I want these all lined up. So I've put colon and then I've said I want it to be 20 characters wide, and it defaults to a string in that case. In which case I've had to convert the range to a string before I can do that formatting. If I just had the R there, I wouldn't have been able to do that formatting on it. So just like before when we converted floats to integers by putting them in an int parentheses, we can convert something to a string by putting it in str parentheses function. How are you going? Are you understanding what we're trying to achieve here and how we've managed to do that in just a few lines of code? Right, so we've shown how loops can repeat sections of code, and that's great when the repeated bit of code is all next to each other and we can just run it over and over again at that point. But sometimes you've got different parts of your program want to call those few lines of code, but they're not next to each other, so we can't loop them. So what we do is we can define a function, and by putting it into a function, then we can call the function whenever we need to run those lines of code. So for example, we can do a function that displays the range, which is what we put in the loop up here. So by putting that into a function, then that can be called from anywhere. So we can, for example, here I've just displayed range 4, and let's run this to see what it does. So display range, that is the name of the function. So I've got def is the Python keyword to say defining a function. Then I put in the name of the function and then parentheses, and then I say what arguments I want to give to that function. So I've just called the argument r. And so when someone calls my function and they put a value in their parentheses, that'll get put into this variable r, and then I can use that variable r throughout the function. Then a colon to say I'm going to start a code block, just like we did for the loops, and a code block is all the indented code. And so it knows that the function definition finishes when it no longer has indented code. So down here is the finish of the function because it's no longer indented code. So it only includes those lines in the function. But it does a nice job of formatting it. It does 20 characters wide for the range, and then it prints all the values of I that are in that range, all on one line, and then prints a new line at the end so that anything else later will print on that new line. Okay, so task 7, rewrite our loop from before, but this time calling the function. So how did we do it last time? I'll copy this one. And then here I can display, and you can see how the code completion is coming up. Display range is the name of my function, so Google's already recognized that as one of my functions. So it's in putting that into the code completion in the Colab, and R is what we're going to display, and it's displayed them all. So similarly, I could use range args in tuple ranges from before, and see how it's remembered from the previous cell. The Jupyter notebooks remember previous cells that you've executed. It will remember the values. If you don't execute the cell, it won't store the value into the variable, and then you can't use it later. So you have to make sure you've got a number in the cell to make sure that it's been executed. And this one's put the range function inside the display range, and range has got the range arguments, just as we did before. So, and that looks the same. All right, thanks, Peter. I'm glad you're enjoying it. So I'd like to hear what bits you find most interesting, because it just helps me when I'm doing future sessions, which bits people are finding boring, which bits people are finding interesting. Especially if you're finding something new. I try to put in some new things every now and then, even for the more experienced people who are coming back to these absolute beginner sessions, just so that they can learn something as well. All right, so we're going to go on. So functions don't need to have arguments. You can have a function that just does something and doesn't need any parameters or arguments coming to it. So for example, here I've done a function show time that just shows you what the current time is. And the way it does that, it calls a function now from the datetime library. Now, datetime library is a standard Python library, but it's not available by default. So if you want to use it, you have to import it. So you import datetime just means that anything in datetime is now available. Yes. So in datetime, there are several classes, and one of those classes is datetime. So there's a class for date, there's a class for time, there's a class for datetime. So we're going to use datetime because that's the values that store both the date and the time. And in that class, there's a function called now that calls a function that will return an object of type datetime that tells us what the current time is. So you can see the format that we're using here. Datetime is the name of the library that we've imported, and then we say dot datetime for the name of the class that's inside that library. Now it could be a class, sometimes it's a module inside that library, but in this case it's a class. And then in that class we call a function. So it's a class function called now, and so we use a dot on that class to call that function. And so we get this long name, but one of the good things about having such a long name is that we know it won't clash with our own names. So if we had our own function called now, then we would just call it with NOW, parentheses, parentheses. But if we want the one out of the datetime library, we can call it from this full name. Now, there are other forms of the import statement, which we won't go through now, that allow you to use now directly. So you can do that if you don't have a function called now yourself, which we don't. So you could have used that other way of importing it, but we won't do that now. Then we take that datetime object and we want to format the time that it comes from it. And so we use this function called string format time. And the way that works is we provided a string, and we do provide these percent symbols for the different components of the date time, and it will show the time in that format. So let's have a look at what that does. So you can see it's got year colon and then percent y, percent capital Y gets replaced with a 4-digit year, percent lowercase m gets replaced with a 2-digit month, percent d is a 2-digit day, and then the hour, the minute, the seconds, and the microseconds. So percent capital H, that's a 24-hour hour. No, it's not. It's in fact yes, it's 24-hour hour. But this is on Google servers, so they're running on UTC time. So they're actually 10 hours behind Brisbane time. So this will give you a number between 0 and 23, and it's given us 08. Right, so that was an example of a function without any arguments, but to call it, you still need to provide the parentheses. And that says you're calling this function rather than just referring to it. Okay, so let's look at some time zones. And there's another library called PyTZ, or PyTZ, which is it's not a standard Python library, but it is included in Anaconda. And so when we're using Google Colab, that includes all the Python standard libraries like datetime, and it also includes those in Anaconda. If you didn't have Anaconda installed when you're running this with just normal Python, then you would need to install PyTZ, which is, you could use the pip command for doing that. So pip install PyTZ will be the command to install that. And that has to be run from the command line, not from a Python console. If you're running it from a Jupyter notebook, you could run it with an exclamation mark in front, and that would install it. In fact, we'll give that a go. So I'll just create a cell up here. And even though it's already installed, I'll try installing it again. And just show you what an install looks like. Requirement already satisfied. Okay, so it says it's already there. So it didn't try to install it again. But that's how you would install it. Okay, in PyTZ there's a property called all time zones, which will give us a list of all the time zones that are stored. And the time zones, so let's have a look at so if I import PyTZ, And the reason I'm having to import it here is because I haven't run this cell yet because there's no number in that cell. So you can see what they look like. It's a list, so it's in square brackets, and it's a bunch of strings. Each one, so you can see it's got quotes around them, so they're just strings. And it's got a region followed by a time zone within that region. So we want to write a function that's going to give us what all the regions are. So what we're going to do is we're going to look through all of these, look for the slash, and then the region will just be the code that's before that slash. So, and we're going to store these regions, and we're going to store them in a set. Now, I could have stored them in a list, but what the advantage of a set is a set is a collection of values, but none of them are duplicated. So if I can just keep putting values into that set, if the value is already there, it doesn't add it again, it just leaves it with the value in there once. So if I put Africa in, it'll have Africa, and then if I put Africa in again, Africa will still be in there once. Now if I was to use a list, I could keep appending Africa to the end, but then I'd get lots of Africas, and so to get around that I'd have to check every time that if Africa was already in the list. But set does that for me automatically, so I thought, well, I'll just use a set. So the way to create a new set is using set open parentheses, close parentheses, and that'll give me an empty set. And then I'll loop through all the time zones. I'll look for a slash in that time zone, so I'll see if I can find it. And if it is in there, then I'll get the index value of that slash, and then I'll add to my set all the characters in that time zone up into the index character. So I'm using stuff that we've done in Getting Started 1 and 2. This is called slicing string. So let me know if you want me to go through that in more detail. But I'll just assume at this stage that you're understanding what's going on. Now, some of the time zones don't have a slash in them. So, for example, New Zealand, in that case, the region is just the name of the time zone. So in that case, we'll just add that time zone into regions. Then I can use the built-in function sorted to sort all those regions into alphabetical order and put them into a list, and then I'll return that from my function. So I'll store that into a list of regions. So let's run this and see what we get as our list of regions. So there they are, Africa, America, it's all in alphabetical order, and it keeps going. There are all the regions. So task 8 is define a function which takes one argument, which is the region name, and returns the time zones in that region. Okay. So first thing we're doing, we're defining a function. So DEF means define a function. And we want to come up with a name. So what are we doing? We're returning time zones in a region. So we'll just call it time zones for region. Okay. And it's going to pass an argument to it. And the argument's going to be a region. So let's call the argument region. Okay. So it's going to be similar to the last one. We can say time zones. I think we'll use a list this time because we know it's not going to be, there's not going to be any repeats for the full time zone. It was just the regions that were repeated. And let's go through all the time zones in pytz dot all time zones. Now we can check if the time zone starts with the region name, then maybe that's that's all we need to do. We just check for that. Dot append that time zone. And then we can return the time zones as a list. And we'll test it. So let's have a look at print time zones. Doesn't know my newly defined, oh yep, it's found it. Time zones for region, and we'll try Australia. There we go, we've got Australia, ACT, Adelaide, Brisbane, Broken Hill, Canberra, Curry, Darwin, lots of time zones in Australia. I think Australia's probably got more time zones than any other country in the world, and it's because each of the different places in Australia have decided at one stage or another in their history to not follow the standard of other places, so they've had to create a separate zone for them. All right, well that looks good. Let's try Africa. Yeah, that looks good. Let's try New Zealand. So I don't know what these are, New Zealand and New Zealand chat, but I'm guessing that New Zealand chat is not a time zone for the region New Zealand. So, because if that was the case, it would be in the region New Zealand with a slash. So we can't really use starts with and then the region. So in the solution that are provided here, I decided that the functionality that we used when we created time zone regions for checking the region, we can use that same code in both the function to get the regions and also the function that gets the time zones for the region. So we'll put that into a function. So I've called that function region for time zone. So given a time zone, what is the region? So it looks for the slash, finds all the text up to the slash. If there's no slash, it returns the full time zone. Then, when I want to find time zone regions, which was the function I had before, I can return sorted, that, and what I've done here, this is using set comprehension to create a set. So I'm getting a bit advanced for you guys here, but just showing you that this sort of thing is possible. So what we've done, the curly braces is what a set looks like. It's like a dictionary, but there's no keys, there's only values. And then I put a loop in here for time zone, in pi time zone, all time zones. And then what I want the region for that time zone to go into the set. So there's my function. And then I run that through sorted and get a list that's back from that. And then when I'm finding all the time zones for a region, I use list comprehension here. So this time I'm using square brackets around the whole thing. Square brackets says I'm making a list. The list is going to be populated with my TZ, and the TZ is my loop variable on for TZ in pi time zone, all time zones. But I can put a conditional after that, which is saying if region for time zone equals region. Now that's a lot of stuff happening in one line. So what I'll redefine that. This is what that would look like if I was doing it without using list comprehension. That's for region. So I'd create a new list. Let's call it equals a list. So that's what the outer square brackets mean. Then I've got this loop for TZ in pi TZ all time zones. I didn't get completion there because I didn't do a dot. If region for time zones TZ equals region, then a colon for the code block for what happens if it's true for my if statement, then I want to append it to the list. And it turns out that this sort of code, these 4 lines of code that I've just written here, are so common that they've created this syntax that allows you to type them all in one line, which is that line there. So you can see what each part of that line corresponds to in this function. Now I'll run this one first so that I've defined region for time zones, and then I'll run this, and so that'll define time zones for region this way. But what that does is exactly the same as what this time zones for region does down here. So let me know if you want me to do the same thing for set. I can rewrite that code, but I think you might be able to work it out from what I've written up here. Just when you create a new set, you can't just use curly braces because they don't think it's a dictionary. You have to use SET parentheses. All right, so let's have a look at our solutions. Time zones for region Australia, we got those regions, that's correct. Time zones for region New Zealand, just the one now. Time zones for ETC. So ETC gives you GMT plus 0, plus 11, plus 12, plus 2. And I think, oh yeah, say down here. So be careful when using ETC time zones because they're not the way I would have expected them to be, and I'm not sure why. There's probably some reason because it's the same in different languages. It's not just a Python thing. I've seen this in Java as well. But UTC, for example, is currently 8:57. So in Brisbane, it's 18:57. I would normally say Brisbane was GMT plus 10, but GMT plus 10 actually gives us 10 hours before GMT, and GMT minus 10 is what it is. So it's basically what we have to do to our time zone to get GMT is subtract 10, and that's how they name the ETC GMT time zones. There must be an ETC thing because I've seen that in Java as well. All right. Print the regions. Oh yes, so we've printed the regions. And help region for time zone. Oh yes, so when we're writing these functions, if the first line that you, after the define the function is what's called the doc string. So you can just put a string in there and that becomes the documentation for that function. So I've put a string in here using triple double quotes, which allows me to put new lines in there. And I've said, this function extracts the region from a time zone. By using the same function of time zones for region and time zone regions, we improve the consistency of data. Okay, and then I close it there, and then I've got a comment which just says the first string in a function is the doc string. So now when I run help on my own function region for time zone, it comes back with this, help on function region for time zone in module main, so that's our main program. Region for time zone, it shows me what the function, how it's defined, and then it gives me the documentation string, which is exactly what I wrote before. So it's a good idea when you're writing these functions. I've put doc strings in all of them to put those doc strings there so that someone else who's using the using the function can call up help on the function and get that doc string. All right, now arguments to a function can have default values. So we saw when we were running the print function that sep and end, well, we saw how end had a default value. So let's run help on print. And so it's showing end, the default value is \n, which is new line. It's also got a separator. So when we had commas between values, it separated them with spaces, and so that's the default value for separator. So separator is the first named argument. All the preceding arguments are unnamed and depend on order only. We're not going to go into unnamed arguments here, but if you want to provide default values, you just say, you put the name of the argument and then you just put what the default value is going to be. So we had a function here, total seconds, which is going to calculate how many seconds in this many minutes and this many seconds. So it's a pretty simple function. It just multiplies minutes by 60 and then adds the number of seconds. But by using named arguments, it means that we can call this function several ways. We can call it by just providing the arguments in the order that they're defined. So that's 32 minutes and 15 seconds. Or we can give the arguments names and then we can call them in any order we like. So we can call the seconds first and the minutes second. Or we can do some by order and some by name. If you do that, you have to do all the ones by order first. And so there's different ways we can call total seconds. So if we want to expand total seconds to take 3 arguments, it's going to be pretty simple. In fact, that's so simple I don't think it's going to be any different to what we've done in solution 9 here. So let's just look at that. We've just put hours, minutes, seconds, and just given them all a value of 0. So now we can call, we don't have to call all of them. So this one here we just call seconds and minutes, and it's just use 0 for hours. We can call all of them by order. We could have just called 2 by order and it would have put in a default value for the third one. But we can just totally rearrange them. And that's what it looks like. So the task here is define a function which converts temperature in Celsius to Fahrenheit. So we provide a named argument Celsius to Fahrenheit. Oh yes, so what we're doing, the other thing we were doing here is returning a value. I forgot to mention that. We did that by using a return value at the end, a return command that says what the value is that we're returning. Oh yeah, we did that with the regions as well. So what's special about this one? Nothing really special. That's pretty straightforward. So I won't even go through that solution because that's exactly what we've been working on. We've provided Celsius, multiply by 1.8, add 32, and that's your Fahrenheit. So we can call Fahrenheit and just put in, and we've just used a variable by, we've just applied the argument by order there rather than by name. And we check. So 0 degrees Celsius is 32 degrees Fahrenheit. They all look good. Right, so now we'll get a bit harder. We want to convert a temperature in Celsius or Rankine to Fahrenheit. So we're going to provide 2 named arguments, and depending on which one they provide, that's what we're going to convert. Now, we want them to only provide 1 argument, so we have to put default values on both of them, so that they can provide one or the other. And we have to do some testing to see that they've provided exactly 1. So if they provide, and I'll just go straight through the solution because there's really only one solution here, so we'll go through this one. Oh no, maybe I'll do. So it's a very simple case of that. We say define Fahrenheit, and the 2 options, we put in the named arguments, and then we just see which one we've got. So we say if Celsius is not none, then we'll just return Celsius times 1.8 plus 32. Else, I just say else. So else will assume they've got return Rankine, and Rankine is like a Fahrenheit temperature. What 1 degree Rankine increase in temperature is the same as 1 degree Fahrenheit increase in temperature. It's just Rankine has an absolute zero value. The zero Rankine is absolute zero, so you can't have a negative Rankine temperature, just like you can't have a negative Kelvin temperature. So let me just provide Rankine minus 459 as the conversion. So I can print Fahrenheit, well, let's say I do Celsius 100, print Rankine, Fahrenheit of Rankine, equals 459.67, and I'll just try print Fahrenheit with no value. So it prints 212 here for Fahrenheit 100. So for the 100, it's put 100 into Celsius, multiplied by 1.8, added 3.2, 32, and got 212. When I provided the named argument Rankine equals 459.67, it's gone, yeah, well, that's exactly the same as 0 degrees Fahrenheit. If I tried to call it with not providing Celsius or Rankine, it's thrown a type error because I've tried to use an equation on none type, because it's used none as the default for this one, and so it's thrown an error. All right, so we could put some error checking in the function, and this way, it when it throws an error, it's a bit more, provides a bit more useful information to the user, and they can work out how to solve it. So for the moment, they're getting unsupported operand type for minus, none type, and float. And we're going to go, well, what does that mean? Like, what have we done wrong? That means that we're trying to use a none and a float with a minus sign. So we'll, to throw an error, we do this raise command, raise value error, and so we'll check if they provide no Celsius and no Rankine, we say value error, you must provide exactly one, not neither. So they're going to know. And similarly, if they provide both, then we say you must provide exactly one, not both. And if you look at these if statements, we've got if Celsius is none, Rankine is none, then there's error. Rankine is not none, we calculate it. Else, if Rankine is none, then we calculate Celsius. If Rankine is not none, then we've got another error. Okay, now if you're running these commands so that's defining the function. Now we're going to call the function, and we know that the function will sometimes raise these errors. And you saw what happened when it raised an error. And if we've got a notebook and we're running through the whole, like you can go to runtime here and say run all. If it gets to any error along the way, it'll stop at that point. And I didn't want this to stop at that point for you guys, so I've made sure that I've caught the error before it stops it for Jupyter Notebooks. So what I've done is I've got a try here, and everything I want to try, which is really try and see if it works, I put in indented, and then I say here, except if I get a value error, then I want to print out what the problem is. So let's run that and see what happens. So it converts these fine, 0 degrees Celsius to 32. The Rankines are getting converted, they look okay. But then when it tries to run this line here, and you can see I'm providing both a Rankine and a Celsius value, I get, there was a problem, you must provide exactly one of Celsius or Rankine, not both. So as soon as it hits that, it throws the value error, and it jumps out to this bit here and said, print there was a problem, and the message of the problem is stored in VE. So that's good. The bad thing is it didn't run this line at all because it jumped out at that point. But at least it didn't stop Jupyter Notebooks or Google Colab from continuing on from the rest of the things that we're trying to do. Okay. Now I'm quickly going to introduce dictionaries. We've done this in Getting Started 1 and 2. A dictionary is like your list, but you can have key value pairs. So the keys here are 10, 20, 30, 40, and you can see the key can be a string. If you don't put quotes around it, it assumes it's a variable name. Unfortunately, I've got a variable here called 40 that's got the value 40. So if I run this, we can see what that looks like. D10 is 10, D20 is 20, D30 is 30, and D40 is 40. And the length of the dictionary is 4. Okay, so now we know dictionaries. We can look at Fahrenheit in a different way of handling the Celsius or Rankine to Fahrenheit problem. So we can provide, rather than fix the names beforehand and have all this logic that we add here, trying to work out if they provided one or two of the keywords, we can put all the keyword arguments into a dictionary. And the way we do that, we use this star star notation. So when you're defining a function and you use star star, it implodes all the keyword arguments into a single dictionary. And if you're calling a function and you use star star, it explodes the dictionary into all the keyword arguments. So in this case, we'll call it the same way, Celsius equals C. But that'll get put into a dictionary. And the dictionary, we can then check the length of the dictionary to make sure they've only provided one argument. Otherwise, we raise an error. And then we can just look at the key that they provided to see whether we're returning Celsius or Rankine. And if they provide something else, then we can send a type error saying it only accepts Celsius or Rankine. So at the moment, it's probably a bit shorter in code than the other. There's not a huge amount of difference, so you could go either way. But let's try running this. So we get the same answers as before. Except now we've got two different sorts of error, type error and value error. So we put two except clauses on this try statement. And it'll just jump to whichever one, which in this case was value error. Okay, now if we want to convert Fahrenheit to accept a third possible temperature type, Kelvin, and there's the formula, Fahrenheit equals Kelvin times 1.8 plus 459.67, then it's just a couple of extra lines. So we just add Kelvin in here, and we can now handle three sorts of temperature conversions. So this is a case where you'd want to use star star keyword arguments in your defining your function. Oh, we had to change our error message as well to include Kelvin as one of the valid values. It means when you're calling this function, you can no longer use ordered arguments. So you see, even in the Celsius case, I have to use named arguments. I have to say Celsius equals C. I can't just put C in there because it won't know what the key is going to be in that case. And the other thing I've done in the solution, so let's run that solution. So remember before I had a try statement and I included all the statements in the try and then the except at the end. Now I've put the try statement only around the statements that are actually going to be a problem, but it means that it will jump, after it's finished one of them, it'll then go into the next try statement and run the next one. So I don't have any lines that are not run. So let's run these. We'll see it does the Celsius conversions correctly, it does the Rankine conversions correctly, it does the Kelvin conversions correctly, and then we check. So it tries to do with no arguments, and we get the error accepts one argument, not zero. So that's a good error message. It tries to do Rankine and Celsius, but it says value error, only accept one argument, not two, and it even returns what the two were that you provided. And then we tried to provide bozos, 100 bozos, convert that to Fahrenheit, and it said that's a type error. We don't do bozos, we only do Celsius, Kelvin, or Rankine. Okay, so that's the end. of the session. I hope you enjoyed that. I hope you learnt something from that. Please put in the comments or the chat which bits you liked the most, and or if you found some bits boring, you can say that as well, and so that it helps me for future sessions. You can click on like if you liked the video. Next week, Arun will be taking the session. He'll do the next 2 weeks, and they'll be machine learning. So they're always interesting. So I recommend have a go at those. And then I'll come back with a slightly more advanced topic at the end of August. And then probably in the beginning of September, first week in September on a Tuesday, that'll be another absolute beginners topic. So it'll be probably much like getting started one again. So I hope you enjoyed that, and I'll keep listening to the chat for a couple of minutes after the video finishes on Slack, and the YouTube chat after the video finishes will actually stop, so you won't be able to post any more comments there. See you later.